Hi, everyone. In this video, we're going to be looking at examples of computing combinations. Now, I just told you that we're going to be doing combinations, but I'm still going to be going through and giving the reasoning as to why we're using combinations and not a permutation for all of these. So our first problem, you have 12 shirts and need to pack 4 for a trip. How many ways can you do this? So whenever we're answering these counting questions, we should always ask ourselves, does order matter? And so in this case, let's say we pick shirts A, B, C, and D. Now, to answer, like I said in the last video, a good way to answer this question of does order matter is to take two things and swap them. So if we swap them and do B, A, C, D, would you consider this a different group of shirts? And so most would say, no, they're not different. And so these are the same outcome. And so in this case, we only care about which shirts we're taking, not the order we picked them. If there was some extra information, like in the last video where we're picking which shirt to wear on day 1, which to wear on day 2, etc., now suddenly with that extra information, now order matters. But for this, where we're just taking shirts, it's just the same group of shirts. And so in this case, order doesn't matter. And so so the answer to this question is no. So we want to use a combination. Now, I did it a little quickly in the last video, so I'm going to do this two ways. I'm going to go right from the formula, and I'm also going to use the sort of shortcut method. So here we have 12 shirts, and we want to choose 4 of them. So we're going to do 12, choose 4. And so this is going to be 12 factorial divided by 4 factorial times 12 minus 4 factorial, which is 12 factorial over 4 factorial times 8 factorial. And now what we're going to want to do is I'm going to want to partially expand this 12 factorial to cancel this 8 factorial. I want to cancel whatever the biggest factorial term I have in the denominator is. So in this case, that's 8 factorial. So I'll just keep expanding. So 12 times 11 times 10 times 9. Now I'm going to stop after 8, and I'll just write a factorial sign to that off. Now I've got 4 factorial times 8 factorial. Cancel the 8 factorials, and I'm left with 12 times 11 times 10 times 9 divided by 4 times 3 times 2. And then times 1, but I won't write that out. Okay, and now there's a couple different ways to do this, right? I could do cancel the 3 with the 9, and then I'll 4 cancels with this 12, and then I'll cancel the 2. I can do this a couple different ways. What I'm going to do is I'm going to observe that 4 times 3 is 12. And so 12 divided by 4 times 3 is 12 divided by 12. So these both cancel. That leaves me with 11 times 10 times 9 over 2. And now 10 divided by 2 is 5. So I'm left with 11 times 5 times 9. And I'll put that into my calculator. And I get 495. And now the shortcut method is to observe when all is said and done, I've got this 4 factorial here, but this 8 factorial is going to cancel with this 8 factorial up here. And I'm left with the first 4 terms of 12 factorial. So this is just the same thing as 12 permute 4 divided by 4 factorial, which is 12 times 11 times 10 times 9 over 4 times 3 times 2. And I can do the exact same thing, cancel here, and I get 11 times 5 times 9, which is 495. Okay, so both of these work. If you're not so comfortable with this one yet, feel free to work with the entire formula. I'm going to do both for a couple of these problems, and then I'll switch to just doing the shortcut version. But if you don't like the shortcut version, feel free to use the entire formula and just make sure you're getting the same answer that I am. So now we have a fairly straightforward one. It's just compute 37, choose 3. So 37, choose 3, using the formula, that's 37 factorial divided by 3 factorial times 37 minus 3 factorial, which is 37 factorial divided by 3 factorial times 34 factorial. Now, again, this is where it's really, really important to not expand all of 37 factorial and use our sort of recursive trick, because that's going to take you forever. 37 times 36 times 35 times 34 times 33 times 32, all the way down to times 2 times 1. It's going to take forever. It's going to be really hard to put it into your calculator. Your calculator is probably going to round it, so you'll get the wrong answer. Don't do that. Just partially expand it. Notice we have a 3 factorial and a 34 factorial. We're going to want to cancel the biggest one. So let's cancel the 34 factorial. And so we can do 37 times 36 times 35. And then we can write the rest as just 34 factorial instead of writing everything else out. So 3 factorial is 34 factorial. Cancel the 34 factorials, and then we can expand this 3 factorial in the denominator to 36 times 35 divided by 3 times 2. So again, I know that 3 times 2 is 6, and 36 divided by 6 is 6. But if you don't know that, you could do this one at a time. So 36 divided by 3, we get 37 times 12, which is 36 divided by 3, times 35 divided by 2. Well, 12 divided by 2 is 6. So we get 37 times 6 times 35, which is 7,770. Doing it the shortcut way, we do 37, choose 3, is 37 permute 3 over 3 factorial. And this is the first 3 terms of 37 factorial. So that's 37 times 36 times 35. So 1, 2, 3. Divided by 3 factorial, which is 3 times 2. And again, 36 divided by 3 times 2 is just going to give 6. So 37 times 6 times 35 is 7,770. And of course, in this question, we didn't have to determine whether we're doing a permutation or combination because we didn't have a scenario. We were just straight up asked to compute 37, choose 3. So there was nothing to decide here. It's just, here's what I want you to compute. This one, we're computing the number of ways to do something, and we had to figure out, well, does this something describe a permutation or combination? Similarly, in this next problem, we have another scenario. You are buying snacks for a party. You see 8 brands and want to pick 2 brands to buy a bag of. How many ways can you do this? And so I'll say 2 different brands. Okay. And so again, our very first question is, does order matter? And in this case, so if I pick Lay's and Doritos versus Doritos and Lay's, would you consider this a different set of snacks? Are these different? If you're going to a party and you see Doritos and Lay's on the table versus Lay's and Doritos, would you say, okay, these are 2 different things? And the answer should be no, because these are the same outcome. Because all that matters here is which snacks you bring. All that matters is which snacks you bring, not the order in which you bring them. Now, how would this be a permutation? We saw in the other example, in this first example, you could make this into a permutation by adding conditions. But so here, it's saying, okay, you're going to pick 1 snack to buy 2 bags of and 1 snack to buy 1 bag of. Now that makes a difference because buying 2 bags of Lay's and 1 bag of Doritos is different than buying 2 bags of Doritos and 1 bag of Lay's. And so order does not matter here since we're not doing that. And so we use a combination. So we have 8 brands to choose from. We want to select 2 of them. And so this is going to be 8, choose 2. And here I'm going to transition to just doing the quick version. So this is 8 permute 2 divided by 2 factorial. So that's 8 times 7 divided by 2 times 1. I'm going to ignore the 1. So 8 divided by 2 is 4. And so we're just left with 4 times 7, which is 28. So in other words, there are 28 groups of 2 snacks that are possible to purchase. Okay, so let's move on. And again, we just have another straight computation. Compute 17, choose 6. So here, we've got 17 permute 6 divided by 6 factorial. So that's 17 times 16 times 15 times 14 times 13 times 12. Right, so this is 1. So I'm starting out to write the 17 factorial. This is how you would start writing it. And I'm only writing the product of the first 1, 2, 3, 4, 5, 6 terms because I'm only choosing 6. And then I'll expand 6 factorial. So that's 6 times 5 times 4 times 3 times 2. And then times 1, but I won't worry about that. Okay, so here we can, so there's a bunch of different ways to do this. What I'm going to do is I'm going to say I see 6 and a 2. So I see 6 times 2, and that's 12. So 6 times 2 is 12. I'm multiplying by 12. I'm dividing by 6 times 2, which is 12. So I can cancel out all 3 of these. And I'm left with 17 times 16 times 15 times 14 times 13 divided by 5 times 4 times 3. The next thing I noticed, I have a 5 and a 3. 5 times 3 is 15. That will cancel with this 15 in the numerator. And so 15 divided by 5 times 3, we cancel it, and we'll have 16 or 17 times 16 times 14 times 13 all over 4. So now 16 is divisible by 4. It's equal to 4 times 4. So 16 divided by 4 equals 4. So we're just left with 17 times 4 times 14 times 13. And so putting that into my calculator, that's 12,376. Okay, and so when we're doing this, especially when we have a lot of terms like this, there's often more than one way to cancel everything. And if you're not comfortable with doing 6 times 2 is 12, cancel all of these, you can do it one step at a time. You can do 12 divided by 6 is 2, and then you can cancel with this 2, etc. And so there's more than one way to do this. In fact, I'll actually do another way right now. So 17 times 16 times 15 times 14 times 13 times 12 over 6 times 5 times 4 times 3 times 2 times, yeah. So I'll do the 12 divided by 6 to get 2. That's 17 times 16 times 15 times 14 times 13 times 2. And then I'll divide the 15 by 5 to get 3. So that's over 5 times 4 times 3 times 2. I'll divide the 15 by 5 to get 3. 17 times 16 times 3 times 14 times 13 times 2. Or actually, sorry, that's not what I wanted to do. Start over. Sorry about that. I'll do 17, 16, 15, 14, 13, 12, divided by 6, 5, 4, 3, 2. And so the first thing I'll do is I will divide the 12 by 4, and I'll get a 3 up here. 15 times 16 times 15, 13 times 3, divided by 6 times 5 times 3 times 2. Now, what I can do is I can divide the 16 by 2 to get 8. And with 17 times 18, or by times 8 times 15 times 14 times 13 times 3. Now we'll divide the 15 by 3 to get a 5. Six times 5. And I'll cancel the 5s. And now we're at a tricky little spot because there's nothing in the numerator that's divisible by 6. But what I can do is I can break this up. 6, 17. What you might have to do is break up the 6 into a 2 and a 3. Divided by 2 times 3. Now you can cancel the 3, and you can divide the 8 by the 2 to get 4. So you're left with 17 times 4 times 14 times 13, which is exactly what you end up with here. So there's many different ways to do this. Do whichever one feels most comfortable for you. Last example, you are at a restaurant with friends and want to order dessert. There are 9 desserts on the menu. How many ways can you select 3 desserts to order? And so here, again, why does the order matter or not matter? We're just selecting 3 desserts to order. There's no indication that the order in which we order them matters. In this case, what matters is which desserts we pick, not the order in which we pick them. Now, what's different is if we had said, right, we're ordering desserts for the table. If we had said you need to pick 3 desserts, 1 for you, 1 for your friend, 1 for your other friend, now the order matters because you receiving the cheesecake is different from you receiving the brownie or whatever. So there's a difference. So in this case, order doesn't matter. It's another situation where the only thing that matters is what is being included, not the order it's being included. And so the way we count this is 9, choose 3. And that's going to be 9 permute 3 over 3 factorial, which is 9 times 8 times 7 over 3 times 2. We can divide by the 9 by 3 to get a 3. 2, and then divide the 8 by the 2 to get a 4. So that's 3 times 4 times 7, which is 84. So there's 84 ways you can order 3 desserts for the table. Again, sometimes it might in fact be a permutation, right? Again, if we were saying 1 dessert for you, 1 dessert for your friend, and 1 dessert for your other friend, then the order matters, right? There's a notion of if I swap 2 things, if my friend and I swap, then that's a different outcome. But here we don't have that information. There's nothing to suggest we have a specific ordering. Okay, and so that's going to be all for this video.